Hi there, this is Miss Nichols, and this is video 10 on unit conversion. The essential question for this video is, how do I change the units of a variable? This is an incredibly important skill both in physics and in chemistry. You're going to use it all the time. It's also something that I actually use in my adult life, and we'll be talking about that in another day in class. We've decided that this skill is so important to you guys that we've actually made it one of the mathematics proficiencies. So you'll be doing a test on mathematics again later on this semester. And in addition to all those other math skills that you've already learned, this is the fourth and final math skill. Some of these problems you'll probably feel like you could solve in a faster, more efficient way. But for this standard, we actually are going to insist that you demonstrate that you can solve this using conversion factors the way we're showing you how to do it in this. And the reason is because that is the best way to prepare you for what you're going to have to be doing in chemistry next year. So we might be more flexible later on in the year, but for now, you do need to learn how to solve unit conversion problems using the method that we're going to show you in this video. So one time you might use this kind of skill is, say you're standing at this intersection in Japan somewhere, presumably, and you see a sign that says Tokyo 70 kilometers, but you have grown up thinking in miles, and so you would like to know how many miles away is Tokyo so you can figure out how long it's going to take you to get there. We're going to want to employ unit conversion to figure out how many miles away is Tokyo. So hopefully something that you've learned in your previous math classes is what happens when you multiply a number by 1. And the answer is, when you multiply anything by 1, the value of that thing does not change. This is really useful in conversions because we are actually trying to change the units of a number, but not change its value. We want our final distance still to be equal to 70 kilometers. We just want to know how many miles that is. So multiplying by 1 is a safe mathematical operation because it doesn't actually change the value of a variable. Some examples: 3 times 1, right? That's pretty straightforward. 3 times 1 is 3. You can do the same kind of process with variables. So y times 1 is y. We saw that when we did cross multiplication. Even for objects, if you have apples times 1, you're still going to have an apple. The way we can use this mathematical statement in unit conversions is we can make a funky different way of writing 1. So you guys are used to writing 1 as a 1, but there's lots of different ways you could actually write something that's equal to 1. For example, 5 over 5, that's equal to 1. So multiplying any number by 5 over 5 should give you the same as that number. 3 times 5 over 5 is still 3. We haven't changed the value of the 3. Or I could even write little equations. So 2 plus 1 over 3. Right? Because the top and the bottom of that fraction are equal to each other, that is equal to 1. So I could say y times 2 plus 1 over 3, and it would not change the value of y. We would still have it equal to y. What we're going to be doing is writing 1s with values and units. As long as the top of the fraction is the same as the bottom of the fraction, equivalent to the bottom of the fraction, the value of the fraction is 1. So since we know that 1 foot is equal to 12 inches, that means that 1 foot divided by 12 inches is still 1. So if I took an apple times 1 foot divided by 12 inches, it's the same as that apple times 1. We're still going to have an apple. So these funky little ways of writing 1 are going to be known as conversion factors. Fractions that are equal to 1 that have different units on the top and the bottom, or the numerator and the denominator of a fraction. Some examples of some conversion factors that you'll probably be using: 60 seconds over 1 minute, because they're equal to each other. That's a conversion factor equal to 1. You might be converting weight, kilograms, into ounces. So 0.45 kilograms over 16 ounces, that they're equal to each other, that's going to be 1. Or the one we saw in the last slide, 1 foot over 12 inches is also equal to 1. You're going to need to create the conversion factors yourself, but it's really easy to do if you have a fact. Okay, so when you know, for example, the fact that 1 kilometer is equal to 3,280 feet, okay, you can make actually 2 different conversion factors. One of those conversion factors is going to be the kilometer on the numerator on the top, so 1 kilometer divided by 3280 feet, that's equal to 1. And the second conversion factor is if you just flip those, right? If you flip any fraction that's equal to 1, we're not, 1 divided by 1 is still 1. So 3,280 feet over 1 kilometer is also equal to 1. You might know the fact that 5,280 feet is equal to 1 mile. Why don't you pause the video for a second and see if you can write the two conversion factors that you can create out of this fact. Hopefully you came up with the two I listed there in either order. 5,280 feet over 1 mile, that's equal to 1, or 1 mile over 5,280 feet. That's also equal to 1. I should point out that just like your equations, we always give you the facts on an exam, so you shouldn't have to memorize any of these random combinations of numbers and units, but you should be able to use them to create the conversion factors just like we just did. All right, now that we have some of the background math skills talked about, let's do a problem with using unit conversion. The first thing I'm going to do is make a no-want list, just like I always do when I'm making a math problem. I know that there are 70 kilometers to Tokyo, and I want to know how many miles it's going to be. The next thing I do is I come up with a plan. Now, each step in my plan is going to be a fact that I know. Sometimes you might only need one step if you can go directly from kilometers to miles, but in this case, I don't have a single fact that lets me go from kilometers to miles. So I need a two-step plan. The first plan, I'm going to convert kilometers into feet. And I can do that because I know that 1 kilometer is equal to 3,280 feet. The second step in my plan is going to be converting feet into miles. And I know that there's 5,280 feet in 1 mile. So that should allow me to accomplish my goal of going all the way from kilometers into miles. Each of these facts is going to be turned into a conversion factor, which is equal to 1, right? So I can multiply my original value of 70 by as many conversion factors as I need to convert the units from kilometers all the way to miles. Each conversion factor that I use is going to change the units in my problem. The tricky part is choosing the correct conversion factors. So for that first fact, kilometer into feet, I have two possibilities, kilometers over feet or feet over kilometers. The one I'm going to choose is the one that lets me cancel out the kilometers I already have. Since I have a kilometer on the top, I mean, it doesn't look like a fraction, but you could make that 70 kilometers over 1. You can see that kilometers on the numerator of that fraction. In order to cancel that out, I choose the conversion factor that has a kilometer on the bottom so that we can cancel out that kilometer on the top. So I'm going to write in my first conversion factor 70 kilometers times 3,280 feet over 1 kilometer. Okay, so that's equal to 1. It's okay to do that. And then I choose my second conversion factor. Now we're trying to convert from feet into miles. That's the second step of my plan. And again, I have feet on the top, and I'm trying to change that into miles. So I'm going to choose the conversion factor that has feet on the bottom of the fraction so that I can cancel out the feet that are on the top already. Then I start to simplify, and what I do is I rearrange the numbers and the units so that all of the values are at the front of my fraction and the units are all at the back. This is allowed with math because you can multiply together things in any order, right? 7 times 4 is the same as 4 times 7. So I just basically am rearranging the order of all of those things on the top of my fraction that are being multiplied together, right? We had 70 kilometers times 3,280 feet times 1 mile on the top. And on the bottom, we have 1 kilometer times 5,280 feet. So I'm just going to cluster them together. So you'll notice all the numbers at the front, 70 times 3,280 times 1. That's all the values from the top, or the numerator of the fraction. And then the units from the top, kilometers, feet, and miles. And then I'm going to divide that whole big ugly number by all the values on the bottom. I got 1 times 5,280, and then the units on the bottom, which are kilometers and feet. For the last step, we're actually going to go ahead and just plug the numbers part of this into my calculator. If you're wanting to do it in one step, which I would encourage, you should make sure that you put extra parentheses around each piece. So I've got big parentheses around that top of the fraction, and then divided by a big parentheses around the bottom, so that you don't run into order of operations problems. When you plug this into your calculator, which I would encourage you to get out and do just for practice, you should end up with 70 times 320, 3,280 times 1 divided by 1 times 5280 should give you 43. So that's going to be the value of my answer. And then the units of the answer, what we'll do is we'll look at our units and we'll see what things are canceling out in the units of the problem. And you should see that I have kilometers on the numerator and the denominator, so we can cancel that out. I also have feet on the numerator and the denominator, so those cancel out. And the units that we're left with, the only thing that's not canceled is miles, which is going to be the final units of my answer. So we have, at this point, successfully converted from 70 kilometers into 43 miles without changing the value of that variable. So take a minute and summarize this. Revisit the essential question. What were the key steps that you needed to take in order to change the units of a variable? Thanks for watching.